Okay, let's go. Find closest person. Easy. You are given 3 integers x, y, z representing the positions of 3 people on a number line. X, y, z, position of person 1, 2, and 3. Position of person 3 who does not move. Person 1 and 2 move toward person 3 at the same speed. Determine which person reaches 3 first. Turn 1 if position 1. Okay. Turn 0 if they both arrive at the same time. Okay, so I guess you can use some logic here. So the simple way would be maybe find the difference between person 1 and person 3, person 2 and person 3, and then find the shorter of the two. So something like this is the simple logic would be, let's say, diff distance from 1 to 3 is going to be the absolute value of z minus x. Distance from 2 to 3 is the absolute value from z to y. And then if the distance 1 to 3 is less than distance 2 to 3, then return 1. Else, if the distance from 1 to 3 is greater than distance 2 to 3, return 2. Who arrives first? Yeah, so person 2 arrives first. And then otherwise, else return 0. Okay, this is the if statement way of doing this. I think I can probably find another way that's slightly more compact. So I think I need to have the distance that's still necessary. Okay, the more compact way would be, can I take the difference of the two and divide by, take the difference of the two, so if it's equal it's going to return 0, but if it's positive, so what am I thinking here? So if I find if, let's say x is the distance from 1 to 3, so let's say a is the distance from 1 to 3 and b is the distance from 2 to 3. If I do a minus b, this is going to be is positive if closer, if 2 arrives first, right? Yeah, 2 arrives first. Is negative if 1 arrives first, and it's going to be 0 if arrive at the same time. But what I want, so if I take the difference between those two distances, I want to remap this to be like 1, this would be 2, and this is 0. So positive number maps to 1. So positive number maps to 1. A negative number maps to 2, and 0 maps to 0. It could be reversed too. It could be positive number maps to 2, negative number maps to 1, 0 maps to 0. If I just do b minus a, what would be the formula? What would be a simple calculation to do the mapping? So if I have a positive number, divided by infinity, rounded up. I don't know if that's really what I want to do. positive number. Negative number. Bring all the positives to a single value, all the negatives to another value. If I can get it to any value, I think I can probably remap it from a single value to be these. Positive number. I do division. I do modulo. Positive number modulo 1. Positive number. Convert it to be multiply times 2. It'd be funny if I could do like multiply times 2, add 1 to it, take the remainder, divide by 2, but then I think if you take the remainder, divide by 2, even if you have a negative number, it's still going to be positive number. Like negative 3 to remainder 2 is still positive 1, not negative 1. Making so hard but easy. Remap all the positives to be just 1. Can we do some sort of bitwise comparison? I don't think so. Like if there was actually a bit on integer that represented whether it was positive or negative. No, that's in Python. I think they do. Python's integer type handles arbitrary precision integers, meaning they can grow as large as available memory allows. While Python integers can be positive or negative, the concept of assigned bit in traditional sense is not directly exposed or relevant in Python programmer. Python manages internal representation of negative numbers, which might involve sign, magnitude, or 2's complement depending on the specifics of Python implementation. Therefore, when working with integers, you do not indirectly let's change the answer. This implementation contrasts with fixed sign integer types in languages like C, which use 2's complement and reserve the most significant bit for the sign. Python's methods sacrifice some performance for maximum flexibility. Yeah. You can see leftmost bit is the sign bit, but yeah, just based on the understanding that pythons can be arbitrarily large integers. That pretty much implies that it's not going to have something like that. Or, I mean, maybe it doesn't imply that, but like you don't know how many bits there are in the integer, so it's like really can't scoot up 31 spots to find the sign of the integer. Yeah. Python uses a variable number of bits to switch. I'm not sure how exactly that's done implementation-wise, but it's like it's obviously not going to be straightforward to find a sign bit. Distance. How do you map positives without using like an if statement? Guess I can ask AI maybe. Is there a way to do a non-if statement to compute? I'm not even sure how to phrase this question is. To positives mapped to 1, negatives mapped to. Okay, maybe this is a Python statement that converts positive integer to 1. Okay, well, yeah, I know how to do an if statement. Boolean conversion. Converts the result of a Boolean test directly to an integer. Int of x greater than 0. So if this is true, it converts it to 1. If it's false, it converts it to 0. Interesting. Okay. I mean, I could do that, I think. So, can I do that? Can I do that? X squared then equal to 0. It's 1. Using numpy signed. So it's going to be true or false. Mother. So I think maybe it could be something like let's say 1 minus integer of distance 1, 3 minus distance 2, 3 times. So if they're exactly equal, I want something that's 0. So I think this would be equal 0. There's still an if statement there. What's the value of an if statement? This exactly equals 0. 0 convert to an integer. So this is going to be true if they're equal. If they're true that they're equal, then this becomes 1 when the true becomes an integer. 1 minus 1 is 0. And 0 times whatever is going to be returning 0. And then the other portion it would be, if this is false, then this is just going to become 1. It's going to return whatever this next portion is. So this next portion determines which of the distances is bigger or smaller. So I think this could be something like, so I want to do, I think b minus a. So I think something with distance of 2, 3 minus is greater than distance of 1, 3. So if this is true, then this becomes 1. 1 yes, like 1 plus this. Nope. So if distance to 2, 3 is, no, actually it's the other way around. If distance of 2, 3 is smaller than distance 1, 3, then distance 2 is going to be closer to 2, it's going to reach 2. So this is, if this is true, then it's be 1. 1 plus 1 is 2. If this is false, it's be 0. 1 plus 0 is 1. Okay, I think that's right. I don't think there's any faster though. This is pretty complicated. This is really convoluted. Yeah, my previous stuff is probably the same speed. Let's go ahead and go with what was the previous stuff? What was the actual speed of that? Probably 0. Took more memory though. So this took 17.96 megabytes. Yeah, whatever. Okay. I'm gonna go with convoluted logic. But the summary here is like pretty straightforward to use simple logic with if statements. To determine what value to return based on distances between 1 and 3 versus between 1 and 2 or 2 and 3. Can also use convoluted logic that tries to do some mapping of booleans to integers to formulate the return value. Yeah, so this is the zero value. This becomes 0 when the same. 0 times whatever is going to be 0. So this is going to return 0 when the distances are the same. It's going to be 1 when their distances are different, and then that will apply this factor. This factor is either going to be 1 or 2, depending on which is closer. 1 if 1 is closer, 2 if 2 is closer to 3. Complexity, not too long. I think, but pretty fast to execute. This is the O1 or constant work. And then space complexity, this can be O1 since no space.